So coordinate geometry is the last topic to cover. I can't promise you that you'll get coordinate geometry, but you absolutely are expected to be able to know this on test day. And it is stuff you used to know. The basics, first off, this is the coordinate plane, because it's called a plane because it's basically in 2 dimensions. There's up and down and left and right. There's no third dimension, like leaping off the page or going down into the screen or whatever, you know. Not that there are no 3-dimensional objects on the GRE, but with the coordinate plane, you only have to track x and y. Some things to know. These are both number lines that go off in infinite directions, or they go off to infinity in both directions. So, and they're both number lines like you would expect. Positive numbers on one side, negative numbers on the other. The positive numbers go up and to the right. The negative numbers go down and to the left. What this means is that the quadrants of the coordinate plane, the quadrants being the quarters of the coordinate plane, always have coordinates of the same sign. So each point on this plane is given 2 values. It's given an x value and a y value, and that describes exactly where that point is. So if you had a point like 2 and 3, so if you had a point 2, 3, you move 2 on the x-axis and then 3 on the y-axis, and it's there. If you had a negative 2 and 3, you do the x-axis first, always. The x value is always the first one. They're usually in parentheses, too. So negative 2 and 3 is over here. If you do 2 and negative 3, 2, negative 3, that's down here. And then if you do negative 2 and negative 3, that's down here. So sometimes a problem may even just tell you that a certain point is in one of these quadrants. It's important to remember that something in quadrant 1 will have positive numbers for both of its coordinates. Something in quadrant 3 will have negative numbers for both. If ever you're not sure, you can even just draw a little one out on your scrap paper saying, oh yeah, these are positive and these are positive, so these guys must be negative down here. It's relatively easy, just you need to be somewhat familiar with this thing. So if they throw out a term like quadrant, you don't say, quadrant, what's that? Ah, I'm going to fail. No. You know, keep your cool. Have seen the word quadrant before, so this should not be news. What you do need to know about lines, though, or what you don't know about lines can kill you, because they could ask you about this. A couple key terms. One is slope. So slope, here we have this symbol here, and that symbol, the delta, means change in. So the slope of a line is the change in its y values. Remember, that's the vertical axis, that's the y. So it's represented as a fraction, the change in y over the change in x, x being the horizontal value. Or as my algebra teacher called it back in high school, he called it rise over run. So for me, that just stuck with me because he always talked about rise over run, and he really seemed to like talking about that. But I guess if he were an algebra teacher and didn't like algebra, that would be pretty sad. Anyway, rise over run, or change in y over change in x. You need 2 x points and 2 y points to compute the slope of a line. Otherwise, you can't see how they change, right? So if you're given 2 points, you can solve for the slope of the line. Okay, what does that mean? So we would change the change in y is in the numerator of the fraction. So we can do 6 minus 3, and then the change in x is in the denominator. We do 8 minus 2. Note that it still works if we do it the other way around. So 6 minus 3 equals 3, 8 minus 2 equals 6, so that equals 1/2. What if we had done it the other way around? What if we had done change in y using 3 minus 6? And then we had done 2 minus 8. Well, 3 minus 6 equals negative 3, 2 minus 8 equals negative 6, negative 3 over negative 6 still equals 1/2. The only way you can mess it up is if you put your change in y over your change in x. That will definitely get the problem wrong for you. If you're looking for ways to get the problem wrong, you can just turn off these videos and not study a day until you take the GRE, because you don't need my help to get it wrong. Okay, so that's the slope. The slope represents how quickly the line is, you know, rising or falling or whatever it's doing. Okay, so, excuse me. So the point slope formula, or also known as the slope intercept form, that's how I learned it, is a form that you can put any a linear equation in to give you the information that you need to solve for drawing it on a graph. So instead of, you know, like 3x plus 2 equals y or something like that, if you put it in the form y equals something. So you solve for y. That's the slope-intercept form, so-called because m here, m equals the slope, this rise over run, the change in y over change in x. M equals the slope, b equals the y-intercept, or b equals the y-intercept. Did I say y? b equals the y-intercept. The y-intercept is the point at which whatever line you're drawing crosses this vertical line. If the line crosses up here at 3, then your y-intercept is 3. If it crosses down here at -4, your y-intercept is -4. And basically, you can find out any other point on the line with one x value or one y value, and then the slope-intercept form. So, by converting it into this form, solving for y, you can figure out a whole lot about your lines. A couple other formulas that you might need to know. This one can be reverse engineered or re-come up with if you need to. The distance formula is the distance between 2 points. These are actually the points that we had before. We know that their slope already is 1/2 because we had these same two. But it's basically the square root of the square of the difference between the x values and the sum of the square root of the sum of the squares of the differences of the x values and the y values. That sounds pretty awful, but really all you're doing is making a triangle, and in fact you're making a right triangle. So this is basically just the Pythagorean theorem. Remember that the square of the hypotenuse equals the sum of the squares of the other two sides. That's okay if you don't remember. We haven't gotten to that geometry section yet. But all you're really doing is saying that if this is one side of the triangle and this is another side of the triangle, that this side squared, plus this side squared will equal this side squared. And you're reverse engineering that by taking the square root of this and going there. If that seems too complicated, just memorize the distance formula. Yeah, that's all you have to do. And then the midpoint formula is if you needed, for whatever reason, to figure out what is halfway between 2 points on the same line. You do need both points in order to figure it out, but you just need the 2 x values and the 2 y values, and your midpoint is the average of the two. Or, so that's the average of the 2 x values, so 2 and 8. 8 plus 2 is 10. The average of the 2 is 5. Y plus the 3 plus 6 is 9. 9 divided by 2 is 9/2. So that point here would be 5 and 9/2. Hooray, we found the midpoint. So just, these are two formulas you can learn, or just remember how to rederive them in the relatively unlikely event of needing them, or a water landing, or whatever else. Okay, so last but not least, related to your coordinate plane, you need to know what parallel lines are. Parallel lines, they could be going in any direction, but the whole point of them is they're parallel. They never touch. They will have the same slope. If two lines have exactly the same slope, they will never touch because they're never getting any closer or any farther apart. They will, however, have different y-intercepts. Note that if I were to just continue these two lines, they cross the y-axis at different points. That's how they have different y-intercepts. If they had the same y-intercept and the same slope, they would not be parallel, they would just be the same line. So parallel lines, different y-intercepts, same slope. Perpendicular lines, they'll have different y-intercepts, likely, they don't have to, but perpendicular lines are ones that meet at a right angle. Perpendicular lines then have negative reciprocal slopes. Let me get rid of this here. So these guys have the same slope. That's supposed to be same. Perpendicular lines have negative reciprocal slopes. What that would mean is if you had one line with a slope of 1/2, the negative reciprocal slope would be -2. So it's flip it over and then flip the sign. And then meet at a right angle. It's not super likely that you'll need that, but again, we're trying to cover all the bases so that you're really familiar with how these work. Vertical lines have a slope of 0. Because remember, vertical lines, or the slope of any line, is rise over run. And a vertical line basically has an infinite rise and a run of 0. Oh, sorry. Vertical lines don't have a slope of 0. Vertical lines have an undefined slope. Because it's rise over run, infinity over 0, you're not supposed to divide by 0. So, undefined slope. Horizontal lines are the ones with the slope of 0. So if they just go on to infinity, parallel to the x-axis, again with rise over run, they have no rise at all. They don't go up ever. And then their run is what's infinite. So 0 over anything as a fraction is 0. So horizontal lines have no slope. Or slope 0. And there you have it.